Welcome to Automotive Electronics lecture series. In my previous lecture, I complete chapter number 3. In that chapter, we have discussed about the sensors and actuators. So we have discussed different types of the sensors and also we have discussed the actuators. Now we start new chapter. And in this lecture, we will discuss about the cruise control. Then after, we will discuss about the digital cruise control. And last, we discuss about the throttle actuator. So in this lecture, we will discuss about these three topics. So now, we start with the first one. So cruise control. So now, to understand the cruise control, I have used this image so you can understand better way. So now first one question come in our mind, what is cruise control? And why we need cruise control system in our automobile or in our car? So we understand here. The cruise control is a system capable of automatically maintaining the desired speed. That means the speed set by the driver without need to press the accelerator pedal. So the cruise control system, by using the cruise control system, driver can set the desired speed. That means if they use the car in the highway, then the traffic is less, then it set the desired speed. So he do not have to use the accelerator pedal. So the car can be driven in the automatic mode. Now, what is the benefit of this cruise control system? So this system is beneficial while driving at a constant speed, as it significantly reduces the driver fatigue. So this system mainly benefit for the driver when they have to drive the car in the like a highway, like a state highway and a national highway. So he can set the speed and the car can automatically drive. So it reduces the effort to press the accelerator pedal. Now we discuss about the cruise control in the further. So when the vehicle reaches the desired speed under a normal driver accelerator pedal regulation of the throttle to activate cruise control, at the speed the driver pushes a momentary contact switch, thereby setting the command speed in the controller. So here we discussed about the block diagram of the cruise control system. So here in the cruise control system, we can see this is the controller, and then after controller is attached with the throttle actuators. And throttle actuators operate the throttle valve, and according to that, its throttle plate is on and off. And then after it is connected with the engine, and also here we have used the speed sensor. So we can see here the controller, there is a 3 signal. First one is a signal from the sensors. The speed sensor sends a signal to the controller. So from that signal, the controller know about the speed of the car. Then there is a 2 circuit. Here we can see the S1 and S2. So here the S1 switch is when we press or the driver press the cruise control, then the connection is connect directly to the controller. And the S2, that means when the driver uses the normal accelerator pedal, that means in the city area or in other area, normally the driver uses the manual control. So for the manual control, there is a S2 switch. So now we understand how this cruise control works. So at this point, control of the throttle position is via the cruise control actuators. The momentary contact, that means one push button switch that set the command speed, is denoted S1 in the figure. So the driver set his desired speed like 60 km per hour, 70 km per hour, 80 km per hour. By switching the S1 switch, and driver set the desired speed, and this signal is goes in the controller. Now, also in this figure is a disable switch that completely disengages the cruise control system from the power supply such that throttle control revert back to the accelerator pedal. This switch is denoted as shown in the figure and is a safety feature. That means here we can see there is another connection as I have tell the S2 switch. That means this is the manual control system. That means the person also control the driver speed by using this S2 switch. And when the connection between the S2 switch and the controller, that means the accelerator pedal is connected with the throttle body or the throttle plate. So by pressing the throttle plate, driver can control the throttle. Now the throttle actuator open and close the throttle in response to the error between the desired and actual speed. So that means what? If I have set the desired speed is 70 km per hour, then if the speed is decreased due to like a hilly area or other hurdles is present on the road, then the error is generated. Like the speed sensor, it sends a signal to the controller, and at that time the speed is 60 and my desired speed is 70. Then 10 km per hour, this speed error signal is generated. Now the controller sends signal to the throttle actuator or the throttle valve is opened by this throttle actuator and is enter the more air in the engine. Now, whenever the actual speed is less than the desired speed, the throttle opening is increased by the actuator, which increase the vehicle speed until the error is 0, at which point the throttle opening remain fixed until either a disturbance occur or the driver call for a new desired speed. That means this setting is remain, but is changed if the driver is changed its desired speed setting, like the driver change from 70 km per hour to the 80 km per hour, then the setting is also changed. So this is the cruise control. Now we discuss next one topic is the digital cruise control. So this is the diagram of the digital cruise control system. Here we can see the speed sensor, same as we have discussed. Then also input-output interface, and this is our microprocessor, or we can say controller. And this is the RAM. We know that there is two types of the RAM, ROM and RAM. And in the here we can also see this is a throttle actuator as connected with the driver circuit for the actuators, and this signal is sent to the throttle. Now we discuss about this. The physical configuration for the digital microprocessor based cruise control is depicted in this figure. A system such as depicted in the figure has digital controller. Here we can see this is a digital controller. This is often called the microcontroller. The actual program that codes the various calculations to be performed is stored in the read-only memory, that means in the ROM. So actual program that perform the calculation is we have stored in the ROM. And typical the ROM also store permanent parameters that are critical to correct calculation. In addition, the system uses the RAM memory to store command speed and to store any temporary calculation results. So here we have discussed about the function of the RAM and the ROM. Now, input from the speed sensor and output to the throttle actuator are handled by input-output interface. So here we can see the input-output interface block. So it is connected with the sensor, and here we use the speed sensor that sends a signal to the input-output interface, and it is also connected with the controller and throttle actuator body. Now the output from the controller is sent via the input output, so it's called driver electronics. The later electronics receive this control signal and generate a signal of correct format and power level to operate the actuator. So in this way, this digital cruise control system is worked. Now we discuss about the hardware implementation issue. So here we can see this is the block diagram of the controlling system, and here we have used two controllers. One is the proportional controller and other is the integral controller. So now we discuss. So the computer continuously read the actual vehicle speed V and generate an error, that is En, at the sample time Tn, and we can also write it as En is equals to Vd minus V at the time Tn. We can say Vd is our desired speed, and this V is the speed at the time T. Now a control signal Un is a computed that has the following form. That is, we can write the control signal in our form like in the proportional and integral form, like Kp En plus Ki sigma m is equals to 1 to m En minus m. Here this Kp is indicate the gain of the proportional controller and Ki is indicate the gain of the integral module. Now this sum which is computed in the cruise control computer is then multiplied by the integral gain Ki and add to the most recent error multiplied by the proportional gain Kp to form the control signal. The compute discrete time control signal Un then must be converted to the piecewise continuous form Ut suitable to operate the actuator. So this is the main issue for the hardware implementation. That means the computed discrete time control signal, that is we can send as a Un, then must be converted to the piecewise continuous form, that is denoted by U bar T, suitable to operate the actuators. Now we discuss about the throttle actuators. So here we can see the figure of the throttle plate, and by using the throttle actuator command signal, we can see this is the throttle plate is open and closed. And as the throttle plate is open, more air is entered in the engine. The throttle actuator is an electromechanical device that, in response on an electrical input from the controller, move the throttle through some appropriate mechanical linkage. Two relative common throttle actuators operate either from the manifold vacuum or with a stepper motor. That means this opening and closing of the throttle plate is operated either by the manifold vacuum pressure or is also operated by the stepper motor. Now we discuss about the stepper motor based actuator. So here this is the block diagram of the stepper motor based actuator system. So the stepper motor actuator is shown in this figure. The basic idea for this circuitry is to drive the stepper motor in such a way as to advance or retard the throttle in accordance with the control signal and UN that is stored in the memory. Actuator signal is in effect a sign number, that is like a positive and negative number, like to open or close the valve. A sign will indicate the direction of the throttle movement, like in the advance or in the return. This magnitude of the actuator signal, like in the binary format, is loaded into the parallel load serial down count binary counter. So here we can see it is loaded in the counter. Now the direction of movement is in the form of sine wave. The stepper motor is activated by a pair of quadrature phase signal coming from the pair of the oscillator. So here we can see this is a two oscillator. To advance the throttle, phase A signal is applied to coil 1 and phase B signal is applied to the coil 2. Now in the opposite way, now to return the throttle, these phases are each switched to the opposite coil. So this is the operation of the stepper motor actuator. Now the vacuum-operated actuator we discuss here. So the driver electronic for a cruise control based on a vacuum-operated system generate a variable duty cycle signal. In this type of system, the duty cycle at any time is proportional to the control signal. Like we understand by help of this example. If at any given instant a large positive error exists between the command and the actual signal, then a relatively large control signal will be generated. That means if the error is more, then the duty cycle percentage is more, then large control signal is generated. This control signal will cause driver electronics to produce a large duty cycle signal to operate solenoid, so that most of the time the actuator's cylinder chamber is nearly at the manifold vacuum level. Consequently, the piston will move against the restoring spring and cause the throttle opening to increase. As a result, the engine will produce more power and will accelerate the vehicle until its speed matches the command speed. So, in this lecture, we have discussed first about the cruise control, then we have discussed about the digital cruise control, and last we discussed about the throttle actuator. So in this lecture, we have discussed about these three topics. Thank you. Hello and welcome to our channel Electronics and Communication Engineering. Congratulations to find us for learning. You are watching a lecture session on automotive electronics that has approximately 15 sessions and more are coming up. We have more than 1200 sessions in various lecture series on courses for electronics and communication engineering. Watch it and learn. If you like it, share it, subscribe it and press bell icon to receive all updates on new session. Enjoy learning.